All right, folks. Thanks for joining today. It is my pleasure to welcome you all to DataBytes with the National Consortium for Data Science. My name is Amanda Miller, and I'm the Associate Director for the National Consortium for Data Science, also known as NCDS. We are thrilled to host Felicia Chen and Jennifer Zhang from GrantScout to present Using Gen AI to Win STTR and SBIR government grants. Before we begin, I want to share a few housekeeping items. We have disabled the Zoom Q&A for attendees. Chat is also disabled to allow Felicia and Jennifer to present without distractions. But never fear, we do offer a place for you to share your comments and questions. We'll get to those at the end of the presentation. And we ask that all questions and comments be uploaded to Easy Retro. That is our crowdsourcing Q&A platform, which we find pretty easy to pick up. Hopefully you do as well. And I will go ahead and share that link in the Zoom chat now. And you are welcome to go ahead and add questions and comments along the way. And towards the end of the presentation, before we get started on the Q&A section, we will provide instructions and a link once again before the Q&A starts. If we don't get to your question during this event, we will address it in our wrap-up materials. And without further delay, I am happy to introduce Felicia Chen and Jennifer Zhang with GrantScout. Welcome, guys.
Awesome. Thanks so much, Amanda. Super excited to be here with all of you guys today. Happy to kick it off with a quick intro first, just so you guys get to know who we are. So yeah, I'm Felicia. I'm the CEO, one of the co-founders of GrantScout. Been working on startups for the last few years. Got into this space since I actually worked on a project where I won 3 STTRs with the Air Force, and previously was an engineer at Apple and Anduril.
Hi, yeah. I'm Jennifer and I am the CTO. So I've been in the AI research space for the last 10 years. I'm excited about trying to approach this problem from an AI angle, and mostly been working at Waymo for the last 3 years as a software engineer, tech lead, where I led the team that worked on reducing simulated collisions with cyclists, and we were able to unlock the first driverless launch in San Francisco when we were able to reduce simulated collisions with cyclists by 96%. Before that, I was a data scientist at Uber, and all throughout the last 10 years, I've been kind of writing papers that were published in Europe's ICML, CVPR, etc. So excited to be here.
Awesome. Yeah, so happy to run through the agenda really quickly. So I think first we'll just go through different ways of how you can get funded for your idea. And then second, we'll really talk about the SBIR and STTR program, which I assume some of you might be familiar with, so we'll give like a quick overview for those who might not be. Then we'll talk a bit more about how GrantScout and us can help simplify that process. And then finally, we'll dive into kind of the underlying tech between how we've done that. And then the last piece is kind of a Q&A session. So yeah. All right. So how to get funded for your idea. There's 2 main ways of funding that I think most people are probably familiar with. The first is VC venture capital. And so typically that's if you're thinking of like, yeah, public unicorns or super high growth startups. It's a stereotypical path where there's lots of capital available, but it's typically going to be like B2B SaaS or other more traditional products. So it's much harder to get if you're doing anything with hard sciences, life sciences, or R&D, just because in terms of incentives, the venture capitalists are incentivized to get as much return as quickly as possible, which means they tend to be more risk adverse for specialized domains that they may not be familiar with. Which leads us to federal grants. And so we're going to spend most of the day talking about grants. These are non-dilutive funding, so it's literally just free money for you to work on your project. There's no repayment obligation at all. However, it is a hard, complex application process, and it does take a longer time to receive the funds. But a couple reasons why people tend to go with grants versus just ownership and control. When you're receiving a grant, it's non-dilutive, which means that you get to own all of your company. And if you want to change direction or do something else, you don't have to answer to anyone else. It's also particularly good for if you're doing anything with social, environmental, or research focus. A lot of grants are for R&D purposes. They're lower risk because of that, and you get to work directly with the government agencies that you might sell to. So this could be EPA, NIH, NSF, or DoD. All right, so the grant landscape is really, really big, but what we're going to focus on today especially are SBIR and STTR grants. And so probably for a lot of you guys today, this is kind of like a great first stepping stone or an ideal grant for you guys to apply. So quick background, basically this spun out of a program in 1982 where federal agencies with a large budget are actually required to set aside 3.65% of that for small businesses. So right now that means annually over 4 billion funds are invested into small businesses throughout all 11 agencies. And so literally we've seen people get awarded where it's just like a one-man shop to maybe a couple people or even more. Part of what's really cool about this is that there's only 3 things that are required for eligibility. The first is you must be majority US owned. Second is for profit. And third is less than 500 employees. And they give this to about 4,000 companies a year. And then typically, you probably want to focus on either phase 1 or phase 2. Phase 1 is you get funds to just develop a proof of concept. So think of it as a white paper. So what's really cool about this is that you can just come in with an idea. You don't have to have any like prototype or traction or sales. We've seen a lot of academics or people who are applying for phase 1 for things they've done from research labs or in school. The second type of phase is phase 2, and so these are grants or funds for actually prototype development. And so this typically is a longer period of performance, but this is basically money for you to develop your initial prototype and kind of test out to see whether or not it's a good fit for the market. But yeah, the couple of things of why this program was created was really just to encourage small businesses to participate in the economy and do really cool R&D. And the government also knows that if you ever want to sell to the government, it's super complex, confusing, and so this is really meant to be a starting point where if you go through the SBIR program, ideally at the end of it, you've built a close relationship or tie with some government end user that they might be interested in actually having you be a government contractor or connect you with a potential prime that you can subcontract from. The other thing we want to call out is the STTR program. And so this is basically the sister program for SBIRs. It's the exact same thing, except for the fact that you must partner with a nonprofit research institution. And so if you're at a university, this is one of the most common types of grants. We see where if you have a small business that you have on the side and you're working with a professor or a research lab, this is a really good way to solidify that partnership and do R&D together. Couple of examples for SBIR and STTR funded companies. So yeah, 23andMe and Biosensics. So you can see the company sizes, yeah, range from like 1 or 2 people. But then through this program, they can get just like the funding to help them kick started, especially if you're in a field where it's harder to get VC funding, and really grow from that. Okay, so about the application process, 4 steps. The first thing to do is you need to be registered. This in itself is kind of an annoying process. You have to go on sam.gov or sbir.gov, upload a lot of documents to prove that your company's incorporated, fill out forms. But yeah, once you're done with that, the second piece is actually finding a grant that fits your technology and core competency. From there on, you plan and write the grant proposal. Typically, most of these SBIR grants consist of 4 things. First is the technical volume. This is like a white paper, can range from 5 pages to 35 pages. You have your cost volume, which basically is your budget. You have kind of a short abstract and a slide deck explaining what you're working on. And then finally, any letters of support. These could be from potential collaborators, professors, folks who think that what you're building could be interesting and might be potential customers or investors if you get funded. The last thing, once you have all of this done, is actually submitting your proposal through the online portal. So this sounds kind of easy or straightforward with the 4 steps. Unfortunately, if you've ever had to navigate this or looked in this space before, you'll know that it's not as easy as it looks, unfortunately. So the first thing is just being able to figure out what to even apply for. So figuring out what you qualify for, what you have an actual chance of winning. It's very difficult to even get registered. It can take 48 hours to 1 week to finalize your registration on the government website, just because there's some processing that they do on their end. So one common mistake we see people do is, they wait until the very last minute to finish clicking the register button, and they don't realize that, oh no, like it actually takes time for the government to go in, check your documents, and then assign you your unique ID. Finding a grant is hard. Each agency has their own opportunities on their own website. A lot of them are hidden. It's not always up to date. There's some conflicting information, and the exact instructions are in like 100-page plus PDFs. Once you get to the actual writing and submission, it takes an average of 100 to 250 hours just to write one of these. The official SBIR portal actually recommends a 10-week schedule to prepare. And there's very few, almost no examples of winning grants. And so basically what you end up with is this giant PDF, and you have no idea what the end deliverable actually should look like. This is literally, yeah, an example of what the instructions are for NIH. And you can see, yeah, it's just like you have to scroll through this and try to figure out what they're actually asking for. So yeah, now we can dive into a bit about what we're working on GrantScout and how we can simplify this process. So there's 3 things that actually help win grants and what we help with. About half of it is writing the actual grant, so making sure you're submitting something that's of fundable quality and is actually compliant. We've seen people get auto-rejected because they forgot to double space or didn't realize that it should have been size 11 font instead of size 10. The government is very, very peculiar about this stuff, and you must be compliant. Otherwise, you will automatically be disqualified. Another piece that is important for winning is scope matching. And so this is actually, one of the customers we worked with. It's just they literally spend engineering hours and manpower going in every so often and trying to figure out what they're a good fit for. And the last piece is biz dev. And so the government is pretty conservative. They want to make sure that you have a proven track record. And so a lot of what's important is if you have like a strong resume or something, you can point to like published papers or letter support from strong professors who are known in the field. They want to know that, okay, you have a background where you can actually perform the research that you're looking to get funded for. A couple of things when you write the actual grant, you want to make sure that what you're doing is relevant to the agency. So the significance section is really important. You want to talk a lot about commercialization. This is a common area where we see people tend to forget about some of the purpose of this program is the government wants to fund companies that have potential to actually commercialize. And so they want to make sure that you've thought about how you can kind of bridge the research to implementation gap there. And then, we talked about this previous slide, but the last thing that's really important, especially early on for some of the phase 1 grants where you're just getting money for the white paper, is they want to make sure that you have previous relevant experience in that field. So a couple tools that we've helped to build for these. So first is we actually have a free search tool where we've consolidated a database of a lot of the relevant federal or state grants. And you can just type in a quick keyword like artificial intelligence and we'll show what's relevant for you. I think this video should play, but this is kind of what it looks like live. So you can literally just go to our website, www.grantscout.com. It's kind of example of what we've done on the tech side, where we've also built out fine-tuned LLM models that take what you've done and generate a grant for you. Sweet. I think we can probably skip through. These are just a couple of pieces of advice. If you guys are actively applying for grants right now, is make sure you reach out to the contracting officer, make sure you have strong letters of support, and make sure you ask for feedback even if you don't win. All right, I'll pass it off to Jennifer and she can dive a bit more on what we're actually doing, what the tech looks like, now that everyone kind of has the background knowledge of what the cyber landscape looks like.
Yeah, thanks, Felicia. Happy to dive into the topic of this talk, which is how generative AI and AI in general can help you with your grant writing. So behind the scenes, there's a couple of areas where we use a lot of AI. Grant search is one of them. So scope matching, this is a huge problem, especially when you are not only applying for grants, but also later looking into contracts as well. And how we do it is we have a two-step approach where step one, we use semantic vector embeddings for retrieval. And this is supposed to be fast and optimized for recall because we tend to have almost tens of thousands of examples in our database that you could potentially be matched to. And we use some kind of public open source embeddings, such as like BERT large, which is an embedding that is 1024 dimensions. And how it works is that we'll kind of chop up the grant into multiple chunks, so potentially 500 tokens, or just some set number of tokens with overlapping intervals, and we will match each chunk to your company description. So if you give us like a paragraph on what your company does, we will try to match your company with grants. Can you go back actually? Yeah, so example of how these embeddings work is that like the embeddings are in this like, here it shows 3-dimensional, but the ones we use are like 1,000 dimensions, and it's pretty sparse, but you'll have each vector represents a phrase or word, and the vector will try to kind of codify like the meaning, the semantic meaning of that phrase. And so you can even do things like subtract 2 vectors in order to get a vector that represents the difference between those 2 phrases or words. And so you'll get like relationships like, for example, the difference between the woman vector and the man vector will look very similar to the difference between the queen vector and the king vector, because it codifies sort of a very similar meaning. And so what happens is that when we take the dot product of 2 vectors, the higher the dot product, the more similar these two basically these 2 embeddings are. And so the higher the dot product, the more likely you will want to apply for that grant. So that's how we kind of whittle down like the 10,000 or so grants that we have in our database into maybe 500. And then after that, we'll want to do a higher precision ranking of those 500. So next step in the grant search is a cross encoder. So we use a cross encoder, which we trained in order to re-rank the retrieved results. And this is slower, but we're operating on a much smaller set, say 500 instead of 10,000. And so we're optimizing for precision of the top, say like 20 grants that you're seeing. You want those to be super relevant. And how we do this is we were able to collect labels in order to train the cross encoder. And we actually use large language models to collect the labels by asking ChatGPT or GPT, like basically, here's a grant and here's a company. Does this company qualify for this grant? And GPT will give us yes or no, and it will give us the confidence of how likely, basically the confidence it has in that answer, and we use that to train the model. And so here is an example of just the entire AI flow. So next, the first step will be this box on the left. This is the retrieval system. So this should be very fast. It interfaces directly with the very big grants vector database. And it fetches the grants, and then it runs it through runs your query, or basically the context from your company, through a status transformer, and then it takes the dot product. Then the next step will be step 2, which takes like the top 500 or so, and it runs it through the cross encoder transformer model, and then it will rank the top 20 or rank the top 50, and then it will present that back to the user. And the user often kind of thumbs up or thumbs down on the results, and that goes back into the flow in order to train the model as well. So this is for a grant search. Next part that heavily relies on generative AI is grant writing. So there's multiple areas in grant writing that rely on generative AI, but obviously the writing part is a big one. And in order to do the writing part, we also use a tool called retrieval augmented generation, or RAG for short. And this is pretty commonly used when you have a lot of documents that you want to parse through or search through, because if you use like GPT, the context window is like 8,000 tokens. I mean, there's like much larger models that have like up to 100,000 tokens, but generally it's hard for a model to kind of take in lots and lots of documents at once and spit out something that's specific and very relevant. And oftentimes when you're writing a grant, there are lots of different input sources. For example, agency keystone documents. So for example, the DoD will often publish keystone documents about their biggest priorities, what they want to acquire, what they want to fund, and what the political landscape is right now. And those are really important to cite when you're writing your grant, because if you can point to a specific like general who said like, I want to acquire XYZ, not only will that help you write the grant, but it might actually help you kind of contact the right people in order to get the right letters of support. There's also past grants, which are, relevant to the current grant you're writing about, but maybe not 100% relevant. You're not like trying to write the exact same grant. You might have a bibliography with hundreds of papers that you need to parse through. So these are all input sources that could go into writing a good grant, but we need to implement something called a RAG to find the most useful information in kind of this large corpus to prompt the LLM. And the RAG actually has a similar architecture as the grant search engine to find the most relevant snippets. It chunks up, the corpus of documents that you have into like 5,000 tokens or 500 tokens actually, and then it will like also kind of overlap the chunks as well, so you don't miss anything. And then it will do a dot product between each of these chunks with the prompt. So next slide. It will. Okay, so basically how it works is that like you've chunked up all of your documents, you have the grant instructions, which ask questions like, can you tell me about the significance of this problem? Can you tell me about what your technical objectives are? Can you tell me about your like key personnel? And so those instructions get basically get dot product with all of the chunks that are in the RAG that have been indexed by the RAG, and then the most relevant chunks in the RAG are then passed into a prompt along with the instructions to the LLM, which then answers the question, and then that becomes kind of the section that you've generated that serves as the first draft for your grant. So you'll basically answer like each of the each of the questions in the grant instructions separately. Okay, so after that, we have a couple of different pieces of the grant writing tool as well that we use a lot of AI. So if you try to use ChatGPT or any other model kind of by itself when you're writing a grant, you'll quickly find that it doesn't do a very good job. It's not really tuned for technical writing or grant writing. It's tuned more for like free-form chat, and it's trained on text that is mostly kind of casual. And so what we need to do is we need to fine-tune the model to be more useful to our use case, which is technical writing and grant writing, so crafting a persuasive grant. And so one tool that we use is called reinforcement learning from human preference. And this is where we kind of try to leverage a lot of the data that we have on successful grants and human written grants, and also just technical documents that we've crawled from sources like Archive, in order to make the model much better at writing technical, persuasive, long form text. And so this directly uses human completed grant applications. Next slide. So here's an example of how it works. We'll prompt the base model for something, say write a biography for Bob, and hopefully we've already passed in a bunch of context, and in the context you'll have like Bob's resume, for example. And then the AI will generate something that sounds more or less like what's in the middle here. It uses a lot of adjectives, it's very fluffy, it sounds AI generated, and it often like doesn't focus on key points. So this is like the base model. And then after that, we'll have like the human generated version, which from past grants will be responding to the exact same prompt, hopefully, as the AI. And then we will basically pass in both of these examples to the prompt as well as the AI generated and the human generated version into the fine-tuning API, or if we're fine-tuning GPT, for example. And that will help the model update its weights so that over time, it generates text that sounds more like the human generated version rather than the original AI generated version. The problem with this is that it requires a lot of data points, basically probably on the order of 10,000 examples of good human writing in order for the model to learn over time how to emulate human writing. And this also the amount of data also scales with the size of the model. And so GPT 3.5, for example, is like orders of magnitude easier to train than GPT-4 because it just has far fewer parameters. And so it's not an extremely tenable solution, especially since we probably have on the order of like 1,000 grants that are high quality rather than tens of thousands. And so the other reinforcement learning tool that we use is called direct preference optimization, which doesn't require any human completed grants, which are very hard to acquire. And so what happens here is that what happens with DPO is that we have the LLM generate multiple possible completions, and then we have a human labeler choose the best completion out of, say, like the 3 completions that it's generated. And as we keep doing this, the model will fine tune, will update its weights based on this preference data as well. So here's an example of how that works. So if we have the same prompt, write a biography for Bob, AI could generate multiple versions, and you can kind of tune the temperature and stuff like that in order for it to generate very different versions. And then a human labeler will come in and choose the one that they like the best. And the advantages of this is that you can label this as, you can basically collect as many labels as you want in a short amount of time. You can collect tens of thousands of labels, and you don't really need like, an expert grant writer or an expert, scientist to be able to do this, because you just need someone to read these 3 examples and pick one that's like obviously the best, or hopefully obviously the best. And so here's like another way to generate lots and lots of data for fine-tuning the model. After that, we have another kind of problem with LLMs that prevents a lot of people from being able to use large language models and generative AI in general in their workflow, which is famous problem of hallucination or factuality. And there was this paper published in Nature in 2023, so at this point it's probably pretty outdated, but it's about how like large language models can be used in science, but it is difficult to use them unless you're using them as zero-shot translators. And what that means is that out of the box, they're really not able to distinguish between fact and fiction. Obviously, reasoning is still a big problem, but if we want to use them, we basically have to strictly couple the prompt and the LLM output with a source that we trust, and basically act as a translator of that source into answers to like different prompts and different questions that the grant might be asking. And so the closer we can tie these things, the more factually correct the output will be. And so fact checking is basically this last piece that we'll talk about today. But what we want to do is when the model generates a sentence, we want to be able to verify the sentence for factuality. Obviously, you don't want to make up stuff when you're writing a grant, and you also don't want to plagiarize anything. People have gotten into trouble there. So we want to be able to verify factuality, and we also want to be able to cite the source. So we use something called natural language inference in order to do this. Basically, if a system finds that a generated sentence or a paragraph was low quality based on the sources that were provided, which we kind of assume are the ground truth, like these are the documents that you're passing into the model, we will regenerate the sentence with the evidence. And the way we do this is, again, using RAG. So RAG is super useful here. It's like pretty state of the art still, and we can use it to find paragraphs or chunks in the ground truth in order to verify or unverify the factuality of a sentence. So next slide. So here's like an example of how that works. We use like a toy example. You can prompt the LLM and ask it a question like, what is the largest mammal in the world? For a grant, it could be like, how many widgets have we sold this month or last year or something like that. Just something that you might put in a grant. But the large language model might generate something that's not factual. It could say something like the elephant is the largest mammal in the world, which is not a super surprising thing for like GPT to generate. After that, we'll use a RAG again in order to match this prompt and this generated text to say something that's in the ground truth, which is like the documents that are passed in that we more or less trust. And we find a similar chunk that says something like blue whales are the largest animals on Earth, blah, blah, blah. Source would be an article from National Geographic that was passed in. And later on, we can even hook this model up to the internet. But then we can ask, say your model, ask GPT, Claude, whatever, and say, does this LLM generate content match this premise or this source? And then your model can tell you like, oh, there's a 12% confidence that, or it's just basically, it doesn't seem like it matches, the factuality score is low. After that, you can then regenerate, pass in this piece that was that we got from the RAG as well as the prompt, and say, can you regenerate an answer to this question using this evidence? And then after that, your LLM could generate something like, okay, it sounds like the blue whale is the largest mammal in the world. Then you can fact check that again, based on your source, and hopefully your model will tell you that this has 99% or a very high confidence. And if it has a very high confidence, then it can even cite what it says using that source that was discovered by the RAG. And so the final response will be hopefully much more likely to be factual than your first response. And so this is kind of a check that we do for everything that we write, to make sure that every sentence in the grant is substantiated by something that has been provided by the user. So or provided by, you know, the government, the DoD, like those documents as well. Okay, so that's basically the last piece of the grant writing tool that uses AI. And yeah, so final slide.
Yeah, so thanks Jennifer for sharing. I think that's kind of, yeah, a quick overview about what SBIR and STTR grants are and how we've built out tools for both the search piece of figuring out, okay, what grants should you apply for, do you qualify for, and then the writing piece as well. And so making sure how can we help you write a grant that actually sounds good, that's high quality and factually correct. Quick sneak peek, we're actually launching our self-service tool pretty soon in the next month or so. So right now we've been doing this kind of as a complete white glove service for a lot of business and startups that we're working with. But yeah, super excited to share this more broadly with all of you guys pretty soon. I think Amanda, do you want to share the easy retro instructions?
Yeah, thanks so much. If you could go ahead and give control to Jayshree, she will share her screen so folks can kind of see what I'm walking through on the Easy Retro board. Let's see. Thanks so much, Jayshree. So here are the instructions for Easy Retro. To add ideas, click on the plus sign in the relevant column header. Type in your idea, and when you're finished, hit the blue box with the thin white check mark to save within the same field. And then your idea will appear on screen for the public's reaction. You can also comment on other folks' ideas by upvoting and just simply press the thumbs up icon. And you can comment on an idea by using the quote bubble icon. So please feel free to use both of those items. The panelists today will be starting with the comments that have the most upvotes. So if you see a question here that you like, go ahead and give it a thumbs up on your device or via the link that we've shared with you in the chat. And if you don't see a question you like here, we encourage you to add one yourself. That would be fantastic. So thanks so much, Jennifer and Felicia. Folks, I'm looking forward to seeing questions from you appear here. And I will let you guys go ahead and get started, Felicia, with the first two questions under grant applications and technical questions. Thanks.
Sweet. Let's see. Yeah, so I think first question under grant applications, can Gen AI be used to apply for academic grants such as K-99s? Yeah, the answer is definitely yes. So a lot of academic grants have the same problems or struggles that other grants do, where it's just like lots of really complex lists of instructions and really technical writing they have to do. It is a harder problem than just normal grants because the amount of like technical depth and expertise and accuracy involved is that much higher. And so we are actively working with quite a few students from MIT on that, but yeah, definitely a use
Yeah.
case that we're working on.
I'll say it's much more difficult because it's a lot denser. Like the technical aspect of writing a K-99 grant is a lot denser than say like a DoD grant, where it's like you're writing for an audience that is less like experts in your field. It will definitely speed up the process because of the many repetitive questions you do have to answer for writing any grant. But it's probably a little bit less of a self-serve tool. It's like probably more just like using it to speed up like 20% rather than 80%. But we are interested in the problem for sure because we love helping researchers.
Yeah. Okay. How long does it take to hear back after applying? Ranges. I would say minimum is 3 months. We've seen it definitely take longer. I'd say maybe average is 6 months, depends on the type of grant you apply for, if there's a lot of like delays or extensions on the government side. But yeah, that is one of the drawbacks of grant funding is just like the timelines.
Yeah. The next question, given that agencies have very different instructions and styles, what agencies have you done this for? So we have done it for NSF, NIH, and DoD, and also other agencies as well. So the part where you have to parse the solicitation and understand it and make sure that you're compliant, create your compliance matrix, everything, etc. right now is being done kind of on a case-by-case basis. But for example, if you do it once for like DoD grants for a particular drop, particular I guess cycle, then generally that applies to all the grants that are under the DoD or under the Navy for that cycle. And so there is like a little bit of kind of making sure that everything is compliant manual work, but it does scale across all the grants in that particular agency for that cycle. However, one thing that we are trying to create next, which is still a work in progress, is the ability to use large language models to scan a solicitation. Usually that's like 200 pages or more, and then create a compliance matrix out of that in order to check like if if you're meeting like the instructions and styles and stuff like that. But that's like work in progress.
Yeah, I think under miscellaneous questions, what will differ between the white glove and self-service processes? Yeah, so for the white glove, right now we've been pretty much like very hands-on, working really closely with the small businesses, like helping with registration, submission, getting letters of support, or just like recommending what you should do. I want to highlight actually that like, yeah, we definitely are not like a magic bullet. Like we're very careful where we want to give you a realistic estimate of okay. You have to have an actual like an idea that you've thought about and some plan for commercialization in a team you've put together so we can help point you in like the right direction or which areas that you're weaker in. But when we go through this right now, we work pretty closely with all our clients, and there is definitely like input that we need from you since you are the subject matter expert in your own company. And really what we help with is making sure so that all you have to focus or think about is your core competency and your business, and we can help storytell it in a way where it's written very strongly for these different grant opportunities and making sure that you're compliant with them. So yeah, for the self-service process, it's going to be just a web tool where instead of you can still have some interaction with us, but it's probably going to be more for companies who are a bit farther along and really helping them streamline and increase their bandwidth by auto-checking whether or not their proposal is compliant, if they've answered everything, if there's different opportunities that they're missing out on.
Let me take the technical questions. Okay, so what about the risk of data leakage? What if the data we have fed into GPT models is being shared with others who have similar research questions? So we get this question a lot. So we definitely sandbox the data that you send us when we're writing a grant for you. We don't fine-tune GPT models based on your data. We only do pass in the data through prompting, which does not get used to train the models. And basically, another thing that we do is that when we use GPT to create a draft, or when we use any model to create a draft for your proposal, it often returns a lot of, I guess, placeholder information. Basically, it's like, here you need to write a hero fact, here you need to talk about your like specific technical merit points, here you need to like put in revenue dollars. And so then we can go in and for your very sensitive information, like hand paste in the numbers or the specific like technology into the placeholders, and the draft that is being created by the large language model makes that like super easy. It's just like, you know exactly where to put everything, but we don't need to pass in the most important or the most secret information into the model. But I would say that generally the people that we've worked with, they know that like, you know, they pass in some of their information into models all the time as prompts, like obviously not for fine tuning. And so they're generally okay with using large language models for most cases, but we do have
Yeah, I think
cases
just
where we
the
don't use it.
basically TLDR there is that like obviously we have NDAs and everything signed with our clients, and the base model that we have is really good at general technical writing for the tone and language, but for every user, like all your data is kept sandboxed, isolated, and we just take that base model and we basically, you can think of it as spitting out almost like a specialized like offshoot or branch that's only for you. And so there is no data leakage at all because of that.
How do you deal with AI hallucinations? Hopefully we answered that a little bit in the talk, but we have basically systems to do citations and also to calculate confidence intervals for the things that we're generating. Model is able to provide confidence intervals for what it generates as well, which we can use. And yeah, so I think just like trying to tie everything that's written by the model very closely with the source data, the source documents that are given to us really helps cut down on AI hallucinations a lot. So, and obviously the user will review the grant as well and give feedback.
Yeah.
Okay. Let's see.
Am I eligible for Civer Sitter if I just started my company or haven't incorporated yet? Yes, you qualify if you have started your company, you have to be incorporated. But that process usually is relatively quick. But yeah, you have to have those documents when you go through the online registration on sam.gov and everything. What do I need to start applying for a SBIR sitter. Okay. So yeah, definitely need a company that you've incorporated. Over 50%, 51% of the folks on your equity or cap table have to be US citizens. You have to have under 500 employees and you must be for profit. Those are the only hard requirements. But general things we've seen that help make sure you're successful. I think the first honestly is just like, yeah, having a strong idea or solution to the solicitation. And so if you're applying for a grant that's I don't know, like software for like carbon monitoring or something environmental related, you want to make sure that you are able to explain like what you've done in the past or what research you have that's directly relevant to it. So they want to make sure that they're funding someone that has like some subject matter expertise in it and has thought about their approach. Other things that are really helpful is, yeah, if you have collaborators and team members that also have experience, that also is really important. So we've seen a lot of folks partner with professors or different labs and research institutions that can help supplement certain capabilities. I think, yeah, the other piece, last piece is really the commercialization aspect. This is like usually the area where we see people are kind of weakest at if they're coming from a more traditional like academic or technical background, just because you probably haven't had to think about it that much. But it doesn't have to be anything like very like a complex business plan or whatnot. They literally just want to see that, okay, you've done like the basic research of what is the market size, who else is working in this space, how are you different, have you thought about how you're going to make money, have you thought about who your first customer is going to be, and so having like being able to think about those questions enough that you can have an answer to is something that, yeah, you want to make sure as you're applying that you've thought through that. How much are the awards usually worth? Jennifer, do you want to take that?
Yeah, pretty simply like 70, like basically phase one's something between like 75 to like 300K, depending on the agency. And for phase twos, it's like 150 to 200 or more, also depending on the agency. And yeah, so basically around that range. Have you used this successfully with an NIH or NSF SBIR grant? Yes, we have. We do quite a few NIH and NSF SBIR grants. It's pretty similar to the other question, which is like who on the GrantScout team has experience with other agencies such as DOE or NSF. We do have grant writers on staff and are hiring grant writers who have experience even before generative AI in writing grants. And for example, one of them has a PhD in like a biotech field. And so basically we do rely on their expertise for both training the model and also proofreading it, perfecting it, doing the white glove service for our customers.
I would say we started off like focusing really on DoD just because like NIH and NSF, they're harder because of the amount of like technical accuracy and everything that comes into it. But I mean, yeah, most of our wins have been through DoD. We, as Jennifer said, one thing that we really care about is just like helping writers increase their output and bandwidth. And so we're not like replacing technical expertise, like you as the user or the company still have to come in with that. But I mean, we've worked with grant writers on other teams where we basically help augment their workflow or make it easier for them to check for compliance or handle the amount of bandwidth or demand that they're working on.
Agencies such as NSF are asking proposers disclosure use of generative AI. Are you concerned some reviewers might treat this as a negative? So we're not very concerned because we've talked to people in these agencies and they're actually trying to use generative AI to write their solicitations as well. And also we think that it's just kind of the trend of, in 5 years, like no one's gonna not be using it. And so, yeah, generally optimistic about its adoption.
Yeah. What is the idea of cost to users or the fee you charge for the service? Varies. So we have a subscription right now for just the matching piece. That's $275 a month, and that basically gives you weekly funding reports, things like Netflix or Amazon of what you're a good fit for. Our writing is kind of ad hoc depending on the customer and size of the grant, but generally we have an upfront cost and a success fee. I mean, our goal is to be as accessible as possible, and so we do a sliding scale based on if you're a student or a really new startup, or we're working with folks who are a bit farther along. They're able to help they prefer like a higher upfront or subscription cost for that.
I guess which models do we use? We use actually a combination of a lot of different models depending on the use case. So we start off obviously using GPT because it's the most common, but we also use a combination of open source models because thinking of moving to open source models eventually if we want to do like very large scale fine tuning. And also it would be really much better for the data leakage aspect if we can guarantee that the models are siloed. Yeah, so, and also then we wouldn't need to rely on like an API. So Claude, which is not an open source model, we've looked at Claude because of its large context window and also Mixtral and Llama.
Okay, I think we're probably right at time now.
Yes. Yes, thanks so much, you guys. This has been amazing. And I'm sure the folks who have stuck around to the very end agree that this has been an extremely informative webinar. So thank you so much. Really appreciate your time and excited to see you guys grow. Wanted to walk through a few announcements about upcoming NCDS programs. We have AI for non-coders coming up on Thursday, July 11th. There's a QR code right there, so you can scan that and get signed up and learn a little bit more information about that virtual event that takes place on July 11th. And then our next slide is about our short course series, Data Matters, addressing a variety of topics that range from intro to Python, basics of R for data science, geospatial analytics, and so much more. So check out that at datamatters.org or via the QR code. And then our final announcement is the September 17th Scaling Up webinar, where Dr. Krista Angala from Elon University will discuss a little bit about their coordinating hub for data competency. It should be a fascinating conversation, and we're looking forward to hosting all of these amazing folks. But for now, thank you so much, Felicia and Jennifer. We are going to, go to our next slide, which is just our gratitude to our audience for joining today. When this session wraps, please take a moment to complete the Zoom survey. Just let us know what you thought. Let us know how we can make these series events better. We are always inviting DataBytes speakers to participate, so take a minute and fill out that form if you're interested. And other than that, folks, I hope you all have a great summer. Take care. Bye-bye.
Awesome. Thanks so much, everyone.
Thanks so much, Felicia and Jennifer. You guys are superstars.
Bye.
Bye.